Hey, hi, my friend. Good evening. Good evening. I thought, despite the celebrations, I thought that I will spend some time with you, and probably we can learn together. For a couple of minutes, we can spend together and learn together. What's the objective behind this particular lecture? Sure, we are continuing our journey on geometry. We have done maybe about 7, 8, 9 lectures on geometry, and then I'm starting a little bit about the mensuration. Mensuration about calculation of areas and calculation volumes, things like that. So, but then we'll not be able to cover both 2D and 3D in the same lecture. So, therefore, probably we will do a little bit of 2D here. Again, in 2D, in the two-dimensional figures are more to do with the areas. Again, in two-dimensional, there are a lot many parameters, so we'll not be able to cover most of it. Probably let's try and see one particular area, and we'll try to keep the lecture a little shorter. That's how we kind of go about today's lecture. We'll keep it little sweet and little short. That's what we kind of do. Yeah, good evening, Keval. Good evening. Yeah, before I get started, allow me to do quick introduction and couple of announcements. Then we will get started out here. So I'm Belvi Srinivas. I've been working in the test prep industry since 2007. That's about 14 years now. And during those years, I did work both on the management as well as on the training side, training the trainers, training the students, contributing to the content work, the management of it. Yeah, so and the one thing that good thing that I developed over those years is the training the students effectively in the area of QA, DI, and LR. That's briefly about me. And yes, so how you can reach out to me using the Telegram group. You can reach out to me on this particular Telegram channel. Yes, for the short counseling or the short, maybe for the short question answers, whatsoever it is. And not only I, if there are some technical issues in the sense like with respect to the subjects or short concerns, there are many active students on the Telegram group. They will try and respond to you. In case if my intervention is required, I will certainly chip in and try to address some of them. Yeah, that's how we can work together out there. So that's briefly about me. And yes, let me do a couple of announcements before we get into the lecture. These are the upcoming batches on the Unacademy Plus platform or Iconic platform, whichever the subscription that you have. You can watch out for this. If you're a CAT 22 aspirant, there is a course starting day after tomorrow. That's for CAT 22. And there is a course starting for SNAP as well. There is an NMAT course which is live, that is going on, and there is a SNAP course which is commencing on 6th. If anybody is serious about SNAP preparation, probably you can take a look at this particular course. Yeah, and there is another batch which has just started, that's on 3rd November. There are some of the very good educators who have launched these particular courses. You can try and take a look at some of these courses as well. But how do you do that? You might have to take a Plus or Iconic subscription if you want to attend these structured courses offered for SNAP or be it NMAT or whatsoever the course that you're kind of looking at. Yeah, so Plus subscription, you have 6 months, 12 months, 18 months, 24 months, even less than that as well. But on these subscriptions, these are the listed prices. On all these listed prices, you get 10% discount when you use any of the educator code, including my code for any of these particular courses. Right? Yeah. Plus offers technically the structured courses. You want to have a structured courses at various levels. Somebody is weak in RC, so you'll always find the structured course in RC which is of level 1. Hey, I'm good in RC. I'm kind of looking at the next level of preparation. You will find a level 3 preparation on RC. You will find a level 2 preparation RC. So once likewise in geometry, it can be in numbers, it can be on algebra, it can be an LR and DI. In various areas you find pretty much structured courses, so that based on your strengths and weaknesses you can look at the offerings of that particular course. There will be a short video for every single course, what they are trying to offer in that particular course, 1 minute, 2 minute, 3 minute kind of video. You can take a look at that and then you can follow that particular course if that suits your requirement. Right? Yeah, in the Iconic subscription, in addition to all the exposure to the structured courses, you also get one-to-one interaction with the mentor. Say how many interactions? If you go with the 6-month subscription, you get about 25 interactions, right? So if it is an annual inscription, double the number. 2 years, in the 2 years, then it about 100 interactions with the mentors. You will get one-to-one interactions with the mentors of your choice. What you can interact about? You can interact about your test preparation plan, or it could be your with respect to your test analysis, where the scores has to be improved. You can make an Excel, you can share that Excel during the meeting, and you can kind of discuss them, what you want to discuss. You can share the study material, you can say that, hey, this is my strengths and weaknesses, and this is the kind of study material I'm trying to follow. All kind of guidance can be sought, including your interview preparation, stating that, hey, this is the answer for these kind of questions that I thought about. Is that fine? Is it in line with the institute's expectation? Things like that, right? That's what you can kind of plan out the meetings with respect to. Great, that brings us to the end of announcements. Okay, so whoever is here, we can exchange some greetings before we start the lecture. Good evening, Keval. Chinmay is here. Good evening, man. And Nandini is here. Good evening, Nandini. Good evening. Yeah, I think we are all set to start despite the festive mood, festive season. Is it okay to spend some time? You are all set to spend some time, or you just hopped in because, yeah, I dropped a message. You thought that, yeah, you kind of just hop in out here, or we can prepare for some time. Yeah. So if we can prepare, you think, then please keep the book and pen ready. Hey, hi Rishabh. Hello. Yeah, keep the book and pen ready if we can do. So that's what we mean by the preparedness. Keep the book ready, keep the pen ready. Yeah, I know. I also forgot, Cable. I also forgot. Forgot to post. I thought that I kind of posted. I forgot. Then suddenly I realized around 9, about 15-20 minutes before the lecture, I thought about it. But then I think yesterday I informed about this, isn't it? I said that we will meet. Despite all this, we kind of meet on every single day. That's how we kind of decided. Was I right? Did I mention it yesterday? I mentioned, I guess, yesterday in the special class, towards the fag end of the special class. I guess I might have mentioned about the plan for today. Yeah, I think Rishabh was there till the end. Rishabh, did we speak about that? Yeah. Is there a delay? Ah, okay. You thought like that, Keval, but then Rishabh was there till the end. So Rishabh can confirm on that. Nevertheless, anyway, we met now. We met now. Let's carry on, right? Yeah. So expected, unexpected. As long as we are ready, let's go on, right? Comfortable? Yeah. Ah, okay. But will you be able? It's raining here in Bangalore. Absolutely no crackers. It's raining for some time now. Rishabh is saying that there are a lot of burst cracker sounds around that. If it is, yeah. If it is too disturbing, don't worry. Yeah, if it is too disturbing, don't worry. So you can watch it later. If you think that it is too disturbing, even with the headphones, you are not able to manage, no worries, right? You can sign off and then you can do that. If you think that with the headphones you can manage, yeah, I would like to have you here. So we all can do that, right? Yeah. Cool. All right. So let's do some reflective thoughts. Let's get started, my friends. Hey, shall we start? Despite all the troubles or the short notice, all of that, shall we start? Or should we cancel? I'm kidding. I'm kidding. Here we are we are here to make things happen. Okay, not to call off the things. Yeah, here we go. A simple question to start with. A simple reflective question to start with. Yeah, circle. I'm picking to start with. I'm picking circle. Go ahead, guys. Go ahead. Maybe I will wait for about a minute. Let's do a little bit of warm up. Simple question to start with. Very simple question. A bit of warm up. Formulas. So we may have to warm up a little bit of formulas. At least this question will revise us the formulas. That's what I felt. What happened? Warming up is taking time. Okay. All right. Area of the sector. Two formulas would have learned. I just wanted you to recall the formulas. Other than that, nothing. All right. The wait for 1 minute was, hey, recall the formulas about that. Hey, is there a noise here? Because there is a lot of rain around me. There is so much of rain around me. Is there a noise? Are you witnessing any noise here, my friends? Are you witnessing noise, or my audio is clear? My audio. Not noise at your end. There may be some crackers going around there. That noise I'm not talking about. The audio is clear. Audio is clear. So you are not getting that disturbance because of rain, right? Yeah, it's all fine. Nice. Okay. Okay. Cool. Cool. All right, Arshit. All right. So let's take a look. Let's take a look. Two formulas we kind of talk about, right? When I talk about the area of the sector, we talk from two perspectives. Say there is a circle. There is a circle, so I want the area of this particular sector. So one, radius is given. Assume that what is given? Radius is given and the angle is given. Theta is given. Radius is given and theta is given. These are the things. What I have written in the green, blue is given. Radius and theta is given. Then we say that area of this particular sector, area. Therefore, you say that area is nothing but, yeah, theta divided by 360 times of pi r square. This is one way of finding the area, theta by 360, because I don't want the full circle. I just want the area of only this particular sector. This is what you could have kind of done. Okay, second one also you would have learned, because while finding the sector, there are two popular formulas that we kind of talk about. The second one, instead of this, r is given and this L is given, theta is not given, right? Theta is not given, this L is given, right? That particular sector, that curve length, right? The arc length is given. This is the arc length L is given, right? Theta is not given, and I'm asking that, hey, why don't you tell me the area of this particular sector? Theta is not given. Then what you do? Yeah, you say that area is equal to R into L divided by 2. I'm sure you would have proved all these things, all that stuff already in the high school. You do all that, and finally you say that, hey, these are the two formulas I should remember. The idea of this particular question was just recall the formulas before we get into the other part of things, right? Before we explore further. Fair enough. So therefore you understand this radius is 7. Given radius is 7. Therefore, all it out of this 22 is what? Perimeter. Circumference, whatever the way you call it. Perimeter is what? Hey, this is 7. Therefore, this is 7. 7 plus 7 is 14. 14 is gone. Therefore, L is equal to 8. Because 7, this is 7. This is another 7. This is also radius, which is 7, which is 14. 14 plus 8 is equal to perimeter, which is 22. That is what is given. Now come back and plug it. Therefore, you say that 7 into 8 divided by 2, which is nothing but 7 into 4, which is 28 square units, solid centimeters square. That is the area of this particular sector. Okay, simple question to start with. I'm not waiting for your confirmation, reassurance that, yeah, we understood. Nothing other than formula. There is absolutely nothing in this particular question. What I meant is, hey, with this question, I'm sending you a signal that formulas be thorough. All right, formulas be thorough. So whether frequently used, most frequently used is this, less frequently used is this. It doesn't matter to us what kind of data comes in the question while we are doing the example in the question in the exam. So sometimes the angle will be given, sometimes the perimeter, sometimes the arc length will be given. We have no idea what data, what kind of data comes. Be ready with all formulas that you have learned in the high school. That's important there. Fair enough. Let's go to the next one. Let's go to the next one. Let's go to the next one. A minute is a good time. All these are just warm-up questions before we unleash ourselves into the lecture, true lecture. Yeah, go ahead, guys. Should I give a little more time? Should I wait for some time? Simple question. Crack it. I'm just counting to myself about 20 more seconds. Okay, so this is how it looks. So what is given to me? Area to ratio of what? Area to circumference, right? So what is area? Pi r square. Say that the circle has a radius of r. Pi r square divided by 2 pi r is equal to 17 divided by 4. Upon simplification, you get r is equal to 17 by 2. Nothing I did. I just simplified it. I simplified it. You say that, hey, I will cut off this 2 with this 2 here. Pi I'll cut off here, r gets cut off there. Therefore, you get 17 by 2. That is the radius of the circle. All right. So let me drop a circle whose radius is 17 by 2, or the diameter is 17. So 17 by 2 on one hand, 17 by 2. Say that AB is the diameter. So O is the center, 17 is the diameter. Now what is he saying? Find the area of a right angled triangle. If it is a right angled triangle, it should be a triangle in the semicircle. There is no choice in the matter. There is no choice in the matter. If it is a right angled triangle, it should be in the semicircle. Otherwise, it's impossible to get the right angled triangle there, because it is inscribed. All right, it is inscribed triangle. It is inside. Inscribed means what? Every particular vertex is on the circumference of the triangle. Therefore, ABC is the triangle I'm talking about, where angle C is 90 degree, because right angle is possible only when you inscribe using diameter. Already using the diameter of the circle, or a diameter of the circle as the hypotenuse. Diameter should be hypotenuse, otherwise you don't get a right angle triangle being inscribed out there. So fair enough, that is what you are trying to get. And hence, and he says that, hey, one of the legs is 15. Take any leg, or let's say that this is the leg, this is 15. All right, now this is 17, this particular side is 17, 8, 15, 17. Therefore, you know the other leg, 8, 15, 17 is the triangle that I'm talking about, and hence the area of this particular triangle. I know the base. All right, these two one, I know the base, I know the height. Therefore, you write it as half 8 into 15. Right, which is nothing but 60 centimeters square. That is the area of this. Hey, there will be choices for this, right? More often than not, there were choices for the questions. What I did is I removed the choices, because the same question can come with the box as well. I give the choice. Already you think that, hey, it appears like this, appears like that. Hey, what if there is a box with a nice number? So I should be able to do that, right? And hence what I do in some of the learnings is, same cat questions, you take it, remove some data, modify the data so that we kind of get some integer, and let know remove the answer option, so that we will be learning both for MCQ and non-MCQ. That's the idea. That's it. Therefore, you find that a similar question you find in cat with the numbers being tweaked, because their numbers can end up with some irrational figures or fractions, etc. I just have to tweak the numbers a little bit so that we end up getting integers sometimes. That is it. Sometimes I leave it as it is, because getting integer is really, really painful. I leave it. It's okay. We can always write root 2, root 3. We can type. What big deal about it? Yeah, fair enough. This question is clear, my friends. Anybody, any doubt here? Anybody, any doubt? Is this clear, everybody? Can some of you confirm in the chat this is clear? If there is a doubt, let me know which part is the doubt. I will explain that particular part. If there is a doubt in understanding this, let me know. Be it in the question, be it in the explanation. Let me know if there is an issue. Nothing, then we'll go to the next one. Yeah. Keval is fine. Rishav is fine. Anybody else? Chinmay, Harshit. I'm just calling some names. Okay, yeah. Don't think others don't think that why not my name. I'm just, because only 2 responses are not great. Therefore, I thought that I will just prompt others as well. Yeah, cool. All right. Okay, next. Let's go to the next one, friends. Yeah, simple one too. Simple one. This was a cat question. Options were there. Options were there. Try this. Warm up. 1 or 2 more warm up. Yeah, then we will get into the theme and close. We'll discuss the theme. A minute and a half, maybe minute I'll give first. Is there buffering? Chinmay, are you trying to say there is a buffering? Somebody please confirm if there is a buffering. Chinmay, it is buffering. For others, is it buffering, friends? First confirm this, then we will do the question. Someone or some others quickly confirm, is it buffering? Confirm, Rishav, Keval. Someone confirm if it is buffering for you, or is it fine? Chinmay, check it at your end because Keval says that it's not buffering. Everything is fine. Please confirm at your end. Guys, I will extend a little bit of time on this particular question. Please crack it. Give me something. All right, now at least get the number to yourself. Get it to yourself. This is one of the easy questions. Not really that difficult or tricky. Yeah, typing answer option in the chat can be tricky, but I will count at least another 20-30 seconds. Get it for yourself. Don't try to type the answer. If you are getting root 2, root 3 and all that, don't worry. Yeah, okay, let's do this together. Cat always loves to squeeze things like this. They squeeze a circle here, they squeeze a rectangle here, or they will squeeze some square or a rectangle here. These squeezing things cat always likes. You will find a lot of questions on this. A lot of questions, not only cat, IIFT, ZAT, yeah. All of them, they kind of now they squeeze the things. The squeezing is something that they kind of like to squeeze more often than not. That's what I kind of see. Squeezing stuff is what I see. So this is one of those squeezers. So all I got to do is what? Hey, do the construction here. This is nothing but the radius. Say this is center O. Let me do a quick construction. Hey, what is this? This is the radius of the semicircle, radius of the semicircle, right? This is the radius of the semicircle. If that is true, this is 90 degrees therefore. So and hence I say that, hey, I will put this out here. If I put this out here, listen to me very carefully. Listen to me very carefully. Let us say that, hey, this particular center, let me call it as P. And let me drop a line onto this. Let me call it as Q, P and Q. Now PQ. Now listen to me very carefully. Okay, this is radius. Hey, what is this OB? What is the length of OB? If this is radius, fine. If that is radius, this is also radius. All right, therefore you say that, hey, in that case the length of OB is nothing but root 2 times of radius from here till here, my friends. From O to B is how much? If I just make one assumption saying that R is the radius of the semicircle, then what is the length of OB? Length of the OB is R and R, because this is R and this is R. Therefore, this is what? All at the other side is what you got to find out. Therefore, other side is root 2R, because it's a 45-45-90 triangle. Fair enough. That is done. But OB can also be written as, listen very carefully. For the time being, let us call the radius of the smaller circle. Let us call the radius of the smaller circle as small r. Radius of the smaller circle as small r. What does it imply here? I want you to analyze only BPQ. Let's analyze only BPQ. There is B here, there is P here, and there is a Q here. Let's only analyze that particular portion. What is this? PQ is what? R. What is QB? QB is also R, because that would be R, and then this is also R. If that is R, what is this here? Root 2R. What is root 2R? P to B is root 2R. P to B is root 2 small r, small case r. Don't get confused between the capital R and the small case r. It's just root 2R. Fair enough. Now what is this? From O, let me call this particular point as X. So now OB can be written as, O to B can be written as OX plus XP plus PB. All right, OX, I am dividing into 3 portions. Travel here, O to X, X to P, and then P to B. Right, what is O to X? O to X is nothing but R. What is X to P? X to P is nothing but small case r. What is P to B? P to B is root 2R. This is where it is. P to B is root 2R. What is OB? We already found out that is another root 2 times of R. Fair enough. Therefore, bring them together. Put these two together, and hence you say that R times of root 2 minus 1 is also equal to R times of root 2 plus 1. And hence you say that r divided by r is root 2 plus 1 divided by root 2 minus 1. Remember this, try and remember this, because some things are very, very important right now. So the whole idea of taking this particular question was try and remember this. In what sense? For example, if I take a, if I squeeze in a circle, in a rectangle or square whatsoever it is, right? So when I squeeze in this particular circle and I squeeze another circle here, the ratio of the radius, if I call this as r and if I call this as another r, small r, right? One of them is a capital R, the radius of the bigger circle is capital R, radius of the smaller circle is r. The relationship is this root 2 plus 1 divided by root 2 minus 1. Now listen to my second point very carefully. Now take a box, take a cube, cube box. All right, take a box there. All right, you take a particular box. Now in that particular box you first keep one big ball. All right, now let's call this as a sphere, big one. This is a big ball. And then there will be some small gap. In that particular small gap, squeeze in a small ball. Alright, there may be a small gap there. Squeeze in that small ball and then close that cuboidal box. Now the ratio of the radius in this box. Hey, firstly take this as a box. Take a cubicle, take a box in the form of a cube, right? And then squeeze in. All right, now squeeze in like this, where that bigger ball touches all the surfaces. Once you kind of close that particular box, put that bigger box. Now a bigger ball. All right, pick that big ball. There is a big ball here, and then there is a small ball here. There is a small ball. Now what do you do here? Put that small ball in that. All right, put a small ball and then close it so that the small ball touches the big ball. The other surface. That's a sphere. Now the radius of this, instead of this root 2, the radius of the bigger ball versus smaller ball will be root 3 plus 1 divided by root 3 minus 1. Remember this, right? Root 2 is for 2D, root 3 is for 3D. We can prove it in a very similar fashion. You guys can take it as a homework and you can go back, take this as a 3D and start working on that. You will get the similar stuff. If required, we will do it while doing the 3D. We'll come back to this question and we will examine that. But remember, since we already did with did with 2D, do it for the 3D as well. It's pretty much similar there. Hey, you got the crux of this particular question. Main point you got what you should remember to get some speed and momentum, because cat is always interested in small squeezing in stuff. So try to remember something about this squeezing stuff. They squeeze some things. They are not being interested in the bigger things. They put some small squeezing stuff out there and they will be interested in that squeezed stuff. They will ask some question on that squeeze stuff. Guys, got this? You got to note down this. You got to, remember this, right? You got to remember for the next couple of weeks. Only Keval is saying yes. Others, no. Others, or it doesn't matter to us, kind of. Is that so? Or are you lagging in the video or something? Why don't you click on the live button and please come to me? Harshit is agreeing, all right. Others, can you just click on the live and come to the live and stay with us in case you have lagged behind because of the delay or whatever it is. Yeah, so I know some of you would be bit delayed, then you will not be able to respond, right? Try to catch up. Great. All right, so having understood this, see if somebody knew this. For example, if somebody knew this, assume that, hey, so for example, all this we did just to understand this particular part, right? But for our more important thing is what we expect that, all right, we kind of remember this particular stuff. For a 3D, we expect that you kind of remember this particular stuff, right? Anushka is saying it's lagging. Guys, please confirm, is it lagging at your end, my end? How is it like? Because in between, Chinmay had the same issue. Now Anushka has this issue. Keval, confirm, did it lag, Rishav? No lag. Guys, please check the connection at your end also. Otherwise, you keep saying that lag, and then I will get delayed. Once before you immediately jump to lag, please tell that. Okay, Srishti also is here. Okay, Ashriya is here. Yeah, guys, others, before you jump to the conclusion that the lag is at my end, which means at the speaker's end, please just check at your end as well. Glitch every 2 seconds. Chinmay, just check. Probably you may have to just close the app and come back. It's to and fro, buffering a bit in the middle every second. Okay. What is that? I didn't understand, Risha, what you were trying to say. Check if I can be on a better connection just in case. Others who didn't face any issue? Keval, did you face any issue? Because it's a very mixed bag. Srishti says absolutely fine. Ashriya says it's fine. Harshit says it's fine. Uh, is it fine now, Risha? Everyone, is that fine? Or should I have to change some settings? I'm trying to figure out. Help me out. Is this fine? Are we good to go? Or I'll end up checking only on this. It seems fine now. Okay. Okay. Yeah, let's go on. If there is a massive problem, let me know, guys. Okay, if it is a big problem, let me know. Otherwise, maybe because of Diwali, networks might have choked at your end or my end, whichever end it is, right? So I don't know. I don't know. I'm just thinking like that. There might be a little bit of choking because many people may be using. I'm not idea in your area, maybe. Right? Okay. Let's anyway look at this. Okay, having understood we are here. Having understood we are here. Area is a square function. Area is a square function. Had I been there, I would have looked at this particular question. I will come to the area. Therefore, r square divided by r square. Area gives me what? Full circle. R square divided by r square. But I don't want r square. I know r by r. But I want r by 2 divided by r. I want r by 2 divided by r. Hey, why r by 2 divided by r? Because I'm interested in the semicircle, right? I'm interested in the semicircle. Sure. All right. Now the area, while finding area, first let me write r square by r square. What is r square by r square? Therefore, root 2 plus 1 whole square divided by root 2 minus 1 whole square. This is what I get. So in this, what I need to do, only the numerator portion. The numerator portion, I should simply divide this by 2. Only numerator. Why? Because the numerator is a symbolic of the full bigger circle. This full bigger circle. It's a symbolic of the full bigger circle. But I want the semicircle in the numerator. If it is a semicircle, make it half. All right, only that portion, make it half. And then simplify this particular portion. Are you with me, guys? If somebody knew this, they would have immediately jumped and written this particular portion. Just a catch in this cat question was divide this by 2. That's it. Rest is fine. This is all you kind of done on this particular question. Good? All good? All good? You can simplify this from here. All good? You just have to simplify from here. You just got to simplify. Yeah, good to proceed to the next one. If something is not clear, let me know. If it is clear, then we'll go to the next one. If you have understood this, okay, y square, because it's an area, right? I got the ratio of radius. I will go to area, but only catch is when I go to area, I get the full larger circle, but I don't want the full larger circle. I simply want the semicircle. I want the semicircle. Therefore, don't forget to divide by 2. Don't forget to divide by 2. Otherwise, there will be one answer option without dividing by 2 as well. Good. All right. Let's move to the next question. Let's move to the next question. Yeah, now we are coming closer to the classical questions. After this, we will start with the actual CAT. This question also came in CAT, but long time back, even before you guys were born. Most of you would be born around year 2000. This was much before that. Yeah, we will start with this so that we will get the idea. Then I will open up to the CAT questions. Recent CAT questions. Go ahead. Typing can be challenged. Don't worry if you are facing difficulty to type in the answer, but get it for yourself. I'm fine. Yeah, okay. All right. So these plannings are important in these kind of questions. How do we arrive? Because most of the CAT questions, there will not be a direct way to find certain pieces of area. There won't be a direct way to find this. What is given to me? He says that ABCD is a square, that is 7, and then the two arcs are drawn with radius 7 centimeter from opposite vertices B and D. In the sense, he took D here and this is the arc. This whole stuff is the arc first he has formed, right? Red ones, red ones. He has formed this particular arc, which means he took a protractor and he put that around it there. That's one arc. Second thing is, then he looked at the other side, which is B. He looked at B and the same radius 7 centimeter when he tried to put that arc, and this is the other arc that he has formed. This is the other side of the arc he has formed. That is what he mean by this. What is the arc line? Therefore, from the green you get this. This is the arc here. From the red perspective, you get this particular arc. That is how it is kind of formed. Okay, I just told you how this particular arc has been formed. That's a construction behind this. And hence he says that now please tell me what is the area of the shaded portion. Fair enough. Therefore, area of the sector centered at D. So area of the sector, how do I find this? Area of the sector centered at D plus area of the sector centered at B, area of the sector centered at B minus area of the square ABCD is my answer. You might not, if you didn't understand what I'm trying to say, listen to me. Let me call this piece as X. Let me call this piece as Y. Let me call this piece as Z. What do you mean by area of the sector centered at D? Area of the sector centered at D means X plus Y. This is what you mean by area of the sector centered at D. When I take the area of the sector centered at D, I get area X and Y. All right, I get X plus Y. What do I mean by the area of the sector centered at B? I get Y plus Z. I get Y plus Z. What do you mean by area of the square ABCD? It means X plus Y plus Z. Okay, simplify this. What is that I am left with here? So X gets cancelled with minus X, Y gets cancelled with minus Y, 1Z is getting cancelled with minus Z. All I am left with is what? Y. Is that what is required? Is this what my answer is? Y is what I wanted? Yes. This is how you kind of proceed on this particular question, right? So in the sense, hereafter what technically happens is, in the sense in the CAT, technically what happens is there won't be a direct way to figure out certain things. We may have to go a little roundabout before we find certain answers. We might have to go a little roundabout. Sure. All right, this is the idea there. This is the idea. So execute this particular idea. What is the area of this particular sector centered at D? I know that. All right, angle theta is equal to 90 degrees. Therefore, 90 divided by 360 times of pi r square. 90 divided pi r square. Of course, the radius is nothing but 7, which we know. How many times I should do that? Because the area centered at B is also remains same. Therefore, you would say that this is 2 times. This is 2 times minus area of ABCD. That is nothing but r square. Why? Because it's the same thing. 7 only. I'm calling it as r. Therefore, you write this as r square, which gives you the kind of answer that you are looking for. This would become your answer. Substitute. Write wherever r is there. Write r is equal to 7. You get the required answer. Comfortable? Everybody is clear on this? Everybody clear? We can simplify this. No big deal about this. Right? This is 1 by 2 times of pi is 22 by 7 minus 1 22 by 7 minus 1 times of r square, that is 7 into 7, or we can simplify whichever way that you want, you can simplify this from here. Cool. Yeah. Okay. All right. All right. Yeah. 28 is the right answer. Okay. Let's move to the next one. Anybody not clear? Just let me know. I'm leaving at one stage so that we can save that little time and use it in the next question. That was the idea here. This is the gold standard. If you remember, type the answer, but typing is very difficult, I guess. So whichever way you want to type, you type, I will understand. If you don't remember the gold standard, please everybody arrive at the gold standard. This is the most classical question in mensuration, the most classical question. I will prove you why. The next 10 minutes, I will prove you that. So many CAT, ZAT, IIFT questions were asked on this gold standard. A lot of people by heart this kind of question. If you know the gold standard, let me know. Don't know, then remember from today. Okay, guys. All right, let's do this. Even if you got the answer, sometimes these are very difficult to type. Difficult to type, don't worry about it. Let's quickly understand how technically, all right, in the high schools, you kind of proceeded on this particular question. Okay, from C, all right, now they took C and they drawn this particular arc, red one. If you say that, hey, from C, how did they draw this particular arc? This is how they have drawn this particular arc. Then what they did, they took D as the center and they have drawn this particular arc. This is what has happened there. Therefore, this is the radius, right? All right, now listen, quickly listen, everybody listen here. Let's say that from D, all right, let me just project two lines. Let me just project two lines. From D, I will project one line. Is this a radius? Of course, yes. This is radius. This is the radius going from D. Is this line a radius? Of course, yes. This line, what I'm writing, is of course a radius. Fair enough. Now let me write another line from here, from C. Okay, what is this? Is this also a radius? Yes, this is also a radius. This is also radius because from C. Now look from C. From C, this is nothing but a radius to that particular arc DB. Similarly, this is a radius. This is already now this line. Alright, this is a radius. Let me call this point as maybe P. Let me call this as point P. Right now, therefore, DP is a radius and also CP is a radius. Now, what about DC? DC is also radius. DC is also radius, and hence, if you look at DPC as a triangle, it is a 60. Or it is nothing but equilateral triangle. DCP becomes an equilateral triangle. Somebody give me a quick confirmation that so far it is clear. Equilateral triangle you could see. That radius part and equilateral triangle is clear because that is the starting point. That is the starting point in case you are lost. That's the starting point. You got the equilateral triangle. We arrived at equilateral triangle because everything is a radius here. Because everything is a radius. DP is a radius, CP is a radius, because everything is a radius, and hence it's an equilateral triangle. Correct? Yeah? Okay. 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 Super. Super. Last I also joined. Very nice. Okay. Now cool. Listen to me. Let me call this piece as X. Which piece? Only that particular piece, right? Now only this particular piece. Let me call this side of the piece as X. Let me call this side of the piece as Y, right? This piece, only this particular piece. Let me call this as Y. Let me call the middle piece as Z. So what I want X plus Y plus Z, right? What I want is I want the X plus Y plus Z. So what I do, I take the area of the sector, right? Area of the sector starting from C. So how much? Only 60 degrees. Area of the sector starting from C, equivalent of 60 degrees. All right, that becomes X plus Z. That would becomes X plus Z. Okay, plus now I will take the area of the sector, area of the sector from D, that is from D, I will go with that particular curve. I go with that particular curve. So only 60 degree portion. If I take that 60 degree portion, what I get here is Y plus Z. I get the area called as Y plus Z. Now I subtract area of the equilateral triangle PDC. Well, what is the area of the equilateral triangle? Area of the equilateral triangle is Z. Area of the equilateral triangle is Z. Now this becomes my answer. How does this becomes my answer? Because Z gets cancelled with Z. All I wanted was X plus Y plus Z. This is how I go about this particular question. Okay, let me quickly tell you one portion. Let me see where is this area of the sector starting with 60 degrees, just in case if you are confused. Where is that X plus Z? I was referring to this. I was saying that, man, just look this portion alone. Let's just take a look at this particular portion alone. Like this, I wanted you to see. I was saying that, hey, look like this. Only look this particular 60 degrees, this piece. This particular piece, this sector I wanted you to see, which I'm going with this. That is what I mean by the area of the sector equivalent of that 60 degrees. What do I get? I will get the value of X plus Z from here. So what do I do here? 60 divided by 360, which is nothing but 1 by 6. Of course, we all know that, but let me write it nevertheless. 60 divided by 360 times of pi r square, right? That is what you write there, pi r square. Hey, how many times? 2 times. Why? Because this is also same as this. Therefore, you would say that, man, this is 2 times of this minus area of the right angle triangle is root 3 by 4 times of r square, because the side is nothing but r here. That is the area of the right angle triangle. Upon simplification, you understand this. This is 1/3 of pi r square minus root 3 by 4 times of r square. This is the gold standard. You should remember. Let me call it equal to G. Remember this formula. It is important. We will see some more CAT questions built on this particular precept. very important. CAT, ZAT, IIFT, if you are preparing for it, this you must remember. There are highly likely chances that this comes in one or the other exams, or very often, not just this year I'm talking about. Often you spot this concept playing a role in one or the other question. Call this as the gold standard, you call it as G, whatever you want to give, but try and remember this particular piece. Is this clear, friends? My explanation is clear. My explanation is clear. This should be clear. That's it. What should be clear is this piece. This is important. This box should be clear. From this box you arrive at this particular box. All good? Now R is equal to 7. No big deal. There is nothing for me to teach from here. Put R is equal to 7, you will get the answer. That's not important to me. Putting R is equal to 7, simplifying, matching with the answer choices, all that is fine. All that is fine. They would have given some answer choice, we will match with it. That's not a worry. But arriving at this is important there, right? Cool? Okay, fine. If you have understood this, note down this gold standard right now. Right now. Note it down somewhere else, because in the next question you can make use of. You can make use of. Think and quickly make use of this gold standard in the next question. Then you will get the answer within 2 minutes. Then you will find the answer within 2 minutes. Yeah, this is how the next CAT question was. One of the CAT question was like this. One of the CAT question was like this. You may say that, hey, can I hash this also and ask? Yeah, you can do that also. Then whatever the answer you get, make it 2 times. All the drama they will do. Now I want this hashed portion. Go ahead, everybody find. Find the answer for yourself. Even if it is difficult to type, it's okay. Sometimes it may be difficult to type. Don't worry, write it for yourself. Just get the logic, write it for yourself, and I'm giving sufficient time for you to understand. Okay, Chinmay has made some effort to type. Okay, no problem. Yeah. Okay, I'm hoping all of you guys might have figured it out in. Yeah, you'll get the roots and all, of course, because in your gold standard it is there, right? Yeah. So how do you do this? Hey, get this whole stuff. Take this D as the central point and get this full area. Let me call this as X, and let me call this gold standard as G. What was this for us? This was our gold standard. This fellow was our gold standard on the previous question, right? Yeah. Yeah, I know. Don't try to type, because answer options will be there in the exam. You simplify, spot, and type, right? You simplify it. So answer options also will be there, root 3 times of all that will be there. You spot it and you type it. That's not a worry there. Sometimes it will be in terms of pi, sometimes it will be not in terms of pi. All that stuff could be there. So what is that I'm trying to expect it here? Simple. From D, get the complete this particular range, x plus y. That is area of the sector centered at D, equivalent of 90 degrees. All it is equal to what? X plus G. Minus, subtract your gold standard. You know your gold standard, subtract it, you will get the answer. That is the way to do it. If you don't know the gold standard, this question will unnecessarily drag it, and it will take time, and people will have a huge hue and cry saying that, hey, these kind of questions take a lot of time, etc., etc. Just like you know some formulas, There are some gold standards in mensurations as well. I'm just picking one of them and I'm trying to talk today, right? I spoke already one other one. Then I said that root 2 plus 1 divided by root 2 minus 1. If it is a cuboid, right, you will say that root 3 plus 1 divided by root 3 minus 1. Like that, all right? If you remember some gold standard numbers, becomes little easier on certain parameters. That's it. Especially that root 3 plus 1, root 3 minus 1 is very important. This part what I spoke about for the cubes, all right, where the spheres being kept there, it's important. Otherwise, by the time you reach here, that itself is one nightmarish thing there. Yeah, okay. Nevertheless, let's come back to this. Hey, what is this complete 90-degree x plus g? Very, very simple. That is 1/4 of the area. That is 1 by 4 times of pi r square, because it's equivalent of 90 degree, that is x plus g. Do I know my gold standard? Of course, yes, we know the gold standard. That's simply 1 by 3 times of pi r square minus, all it was minus root 3 by 4 times of r square. Simple. Apply this particular gold standard, you will get your answer. What is the value of r here? 7. So you can naturally, all right, because there is a pi here, you can club these two terms together and keep this fellow separate and work it out, and you will get some answer there. Of course, there will be certain options given there and you got to match with how they have done it. So based on that, you try and figure out. Pi sometimes would have been taken as 22 by 7. Sometimes they wouldn't have taken. They would have left the pi as it is. Figure out how they have done it and find the answer there. Okay, clear on this? Had you known the gold standard, how you can actually close this question within 1 minute? It becomes a 1-minute question just because you know the gold standard. Comfortable? Made some sense? Everybody made some sense? Just that you should be aware of gold standard. Just if you are not aware of the gold standard, it will just rob your time. It would just simply rob your time by the time you arrive at it. Guys, clear? Other than Keval, Rishav and Anushka, can I get some more confirmations that yes, the gold standards help? In the sense, what I'm trying to educate you is, hey, in the mensuration, there are certain figures which will take them as gold standard and use them. That's my point. And use them. Genuinely use them. Yeah, cool. All right. Use this another one. See, in the previous question itself, there would be years in which they say that, hey, I will give this one also. I will give this one also. Nothing. Whatever the answer you got, you make it into 2 times. That's it. If they give this, make it into 2 times. What big deal about it? Make this into 2 times. Some other year, what they will do, they will say that, hey, I want this also, man. I want this also, right? I want this, I want this, I want this. Okay, no problem, right? From the whole figure, remove the gold standard. What is that? Full square is there. From the square, remove the gold standard, you will get the answer, right? So that's what you kind of keep working on that particular one, all right? That is what you kind of do. Some other year, they may say that I want only this x and this is y, right? I want only these two pieces x and y. You want only these two, all right? Now these two kind of pieces x and y. So we have to navigate. You knowing the gold standard will certainly help us to arrive at only this piece versus this piece. Anything that they ask us, we will be able to do. So for all these kind of requirements in a square, when they use the same side and produce these arcs, etc., and they will try to squeeze on this, the gold standard becomes this middle figure, for which it is always advisable to remember the formula. Now that you know the gold standard, quickly close this question to yourself. Close it to yourself. I want only this piece, hashed piece. What would be the area of that? Close it to yourself. Maybe a minute, good time, because I am not expecting you to simplify the answer. How do you arrive at it? Just make a plan of action and leave it there. Okay, what if you don't know the previous answer, Rishabh? Assume that we don't know the previous answer. How do we do that? How do we do that? If we don't know the previous answer, how do we do that? Assume that we know this gold standard alone. Can you guys think and give me something there? Okay, let us call this as x. If you want to call this piece as y, you can call this as y. Let this also be y. How do we do this? Assume that we only know gold standard. We don't know anything else, because can we remember too many things? I don't know. Right? Yeah. So not having the previous question. I understood, Rishabh. I understood your point. But what if we don't know the previous one? Looking at this, can you guys type the roadmap? Don't give me the formula, etc. Just tell me the roadmap. In terms of x, y, g, you tell me the roadmap. Do you consider the square there? From the square, what do you want to remove? Can you give me the roadmap? Assume that you know the direct formula for g alone. You don't know anything else. You just know the formula for g alone. Yeah, Keval tried to give. One thing is missing there, Keval, I guess. You just missed one thing, Keval. What did you miss? Two times of, right? Oh, okay, semicircle you wrote. All right. Semicircle. Okay, fair enough, fair enough. You wrote semicircle. Okay, yeah. You worded it as semicircle. Okay, so that's right. Okay, so what you do is first take square A, B, C, D. Listen, everybody listen, because assume that you know only one thing. That's my point. My point is we know only one thing. Using one thing, we will try and figure out all pieces. This piece, this piece, this piece. Every piece we should know by knowing one thing in this particular diagram, because we can't afford to remember too many things on one single diagram. That is the point I'm trying to make, right? Okay, so I will first find the area of the square ABCD. What do I get if I find the area of the square ABCD? I will get this. Okay, let me give a different name here. Let me call this as Z. Y is equal to Z, no doubt about it, but let me call it as Z. For the time being, let me call it as Z. I know that Z is equal to Y. ABCD is nothing but X plus Y plus Z plus gold standard. I got the area of the square minus 2 times of area of the sector. 2 times of the sector, area of the sector of that 90 degrees. Already now one sector from D, the other one from C. What do you mean by 2 times the area of the sectors when I do this? Okay, if you want me to elaborate this, let me write it like this. Area of the sector at D corresponding to 90 degrees minus area of the sector at C corresponding to 90 degrees, right? If I do this, what is that I'm trying to say? Minus of corresponding to D means Y plus G, corresponding to C means Z plus G. All right, this is what you do. If you do this, if you take a look at this so far, okay, so what is happening? Z is getting cancelled with Z, Y is getting cancelled with Y, G is one of the G's is getting cancelled with G. I have one G extra. I just wanted X, but I have one G extra. Now this is where you kind of use the gold standard. Therefore, what you do, you will come back and add the gold standard. Just come back and add the gold standard. Then your one negative G gets cancelled with this and you get only this. That's what it is. A finding area of square, very important, very easy. Finding these sectors, of course, you can club both of them. And just like Keval said, can I call this as semicircle? Yeah, whichever way it is. That's easy. That is no big deal there. Gold standard, you already know. That is how you arrive at this particular piece. Okay, comfortable? Everybody comfortable on this? All comfortable? Just knowing gold standard, we can arrive at any piece within this circle. That's my point. Any piece within this particular circle. Comfortable, everyone? Thought is clear? Yeah, writing these areas are no big deal. I can always write this area. Writing this hardly takes any time. Writing this hardly takes any time. And we already mugged up the formula for gold standard. Hey, other than Keval, others are clear. That's right, Chinmay. Chinmay is right. So Chinmay, Risha, whatever you guys have put in there in the chart is correct. That's the roadmap. My point is what? In the CAT or ZAT or IIFT kind of exams on the mensurations like this, you will not have a direct formula. Remember that there won't be a direct formula. Direct in the sense, nobody will ask you direct question. Hey, from the square, you subtract this, you will get the answer. No, you may have to go little roundabout, sectors, squares, all that stuff. You may have to go little in between, you will get an equilateral triangle. There is always going little bit of roundabout is what they test. And hence it appears like it consumes time. Why? Because we don't set the benchmarks. Set benchmarks not only in this kind of question. I'm sending you that signal whenever you are writing your mocks, etc., etc. You get some benchmarking kind of questions. Remember them. Put it on your cheat sheet, that's formula sheet, and try to remember those areas as well. Not just the broad formulas, right? Not just the broad area of the sector is a broad formula. From area of the sector, arrive at what we want. Something like these kind of standards in between, intermediate standards. That always helps to get the speed and momentum. All right, so here comes the next one. This is the CAT question, word to word as it is. This is the CAT question word to word as it is, just that I removed answer options. I removed answer options. Otherwise, it's a CAT question word to word as it is. Try and interpret this particular question. In one of the classes, I was talking a little bit about the chord. I guess it should make some sense. Yeah, okay. Because of want of time, I'm closing it here. Closing in the sense I'm just calling it off. So I will do it. So just watch this. And if anybody wanted little more time, I'm sure I know that, okay, some of you may wanted little more time. Hey, what is that I want? Ultimately, I want this, right? So this is the rectangle we are trying to squeeze. This is the rectangle we are trying to squeeze. If I call this as ABCD, I have to tell the ABCD here. In the sense, I should know the length AB is how much. This is what I need to know. And I need to know what is the length of BC. What is the length of BC? BC is nothing but the common chord. So BC can also be written as, if I call this point as M and if I call this point as N, MN is nothing but the common chord, which is nothing but the length of this particular rectangle. Okay, what is DC here? DC, I can go here. Say this center is X and this particular center, if I call it as Y, well, this common portion is nothing but this. So it's very, the AB length is very, let me call this point as P and let me call this point as Q. PQ is equal to AB. The length of PQ is very, very simple. Hey, what is PQ? 10 plus 8, 18 minus this particular number 14. 18 minus 14, which is equal to 4. Therefore, getting the breadth was not a problem. Getting the breadth was only 4. Therefore, you say that, hey, if this breadth PQ, all right, I'm talking about this PQ is 4. That is very simple arithmetic there, that you get it as 4 because you have that there is 10 plus 8, 18. All it had the centers been touching, had the circles been touching, then the overall would have become 18 because this is 10 and this is 8. Therefore, overall it would have become 18. So which has become 14 there. If it has become 14, then what has got eaten up? What is common between the two? 4 is common between the two, and that is what the measure of PQ, which is very easy to get. We kind of by now aware of these kind of small arithmetics there. You can write, you may say that no sir, I will call this particular length as L1, I will call this common area as L2, L3, then find L2. You will understand that L2 is nothing but this 4 only. No big deal about that. Okay, now what I need to find out, this Mn. What is Mn here? The length of the common chord, right? And this is what we discussed in one of the lectures. Okay, can I say that the breadth is 4 units? The breadth of the rectangle is 4 units is clear? Shall we close that, or you want an explanation there? Is that clear? Shall we close? The breadth is 4. We just have to find length now. Hello, everyone. Shall we close the thought that the breadth of the rectangle is 4? I have a rectangle here. I need a rectangle here. The breadth is 4. I am just interested in finding the length now. Length is nothing but the length of the common chord. Shall we close the breadth? I'm asking you. If you don't need any further understanding, the breadth is 4. Is that clear? Length is coming irrational. So be it. No problem. No problem, Rishabh. I removed answer options. I told no. Let it be irrational. What big deal? Answer options will be there in the exam, right? Answer options would be there in the exam. Answer options also would be irrational. No issues. Okay, yeah. Breadth is clear. Now let's quickly go to the length. Therefore, let's go to the length. Let's go to the length. We spoke about this. What did we speak? If I join the centers, if say this center is P, this center is Q. Okay, this PQ we already used. Let me use X here. And if I call this as Y, and this particular point, if I call it as M, X to M, and then I know that, hey, okay, from here, the line joining the centers divides the common chord orthogonally. That's what we discussed. Line joining the centers of the circle divides the common chord, bisects the common chord orthogonally. If I call this particular point as O, let us say that if this particular point as O, what I'm trying to say is MO is also equal to ON. What is the length of the common chord? Of course, the length of the common chord is MN. But let me get MO, and then from there I can figure out the rest of the issue. How do I get MO here? I know this particular length XM is 10 units. X to M is 10 units. I know that XY is 8 units. XY is 8 units. And I know this is nothing but H units. Let's say that the height that is MO is equal to H. Let's say that is H units. Let us call that as H. Let us call that particular one as H. And let me call this particular distance as D. Let's call this as D. Therefore, the other side I can write this as 14 minus D. Till where it is D? OY is equal to D. I am calling OY is equal to D. Therefore, the rest of the issue becomes 14 minus D. Okay, in the triangle, let me first go to the triangle X, M and O. In the triangle X, M and O, in this H square is also equal to 10 square minus 14 minus D whole square. H square is equal to 10 square minus, that is 10 is a hypotenuse, therefore 10 square minus 14 minus D whole square. I can simplify this. Then come to the second triangle. Which side of the triangle? I'm highlighting this. Go to the triangle MYO. Focus on the triangle MYO. In this particular triangle, H square can also be written as 8 square minus D square. I can also write it like this. Now I can equate both of them. Because D square, I can equate both of them in the sense because both of them are referring to H square itself. Therefore, I can get the value of D square from here. Anybody quickly, if somebody can solve and let me know the D square there. Can one of you quickly let me know the D square? It should not take much time. You can get the value of D square, whatever you are getting there. This is all you got to solve. 10 square minus 14 minus D square is also equal to 8 square minus D square. D square gets cancelled. You will get the value of D. You would get the value of D first. One of you quickly plug the value of D. D square get cancelled. It's a linear equation. You could see on the face of it, you could see it's a linear equation. Okay, 40 by 7. Sure. Let's take D is equal to 40 by 7. Okay, D is equal to 40 by 7. So once you take D is equal to 40 by 7, come back to one of these triangles, any triangle. Let's say that I will go back to this particular triangle, XMO. I'll go back to let me go back to this triangle, MYO, call it this one. So MYO triangle, substitute, you will get the value of H square. Therefore, H square is equal to 8 square. I'll let you get this. H square is equal to 8 square minus 40 by 7 whole square. Yeah, as Rishabh said, already some time back, already it may not be a great number, but you will get some number called as N. H square is equal to N. Therefore, this is H square. I'm just substituting the value of D out here. So simplify it. Simplification might take some time. Therefore, you say that H is equal to under root of N. You get some fraction. Let me call that. You get some fraction called as F. What I'm saying, H is equal to under root of F. But what you wanted 2H. 2h is equal to 2 times of root f. I'm just giving you a roadmap. I'm just giving you a roadmap. You get 2 times of root f. Fair enough. So once you get the 2 times of root f, go back and substitute that in your answer. You got 2 times of root f, that is your length. Therefore, you say that length is equal to 2 root f. What is that f? F is some fraction that you are getting, and you know the base is equal to 4. All right, length into breadth is equal to 4 units. Therefore, your overall answer area is equal to 8 root f. That is how it reads, 8 root f, something like that. That f value could have been, already you can figure that out. Is that fine? Is that fine? Okay, YouTube issue, maybe. Yeah, YouTube issue, whatever it could be, guys, possible. Whatever it is, try and match it. Yeah, you got the idea how to find these areas. This was the CAT question. This is how they asked on. So this is what we call under mensuration. Whenever areas come in, we say that little bit of mensuration comes in the picture, right? That's what we kind of call it. Okay, let's do one more question. All right. Try this, everybody try this. This is simple one. A minute and a half should be good for this. Try this. Yeah, typical cat. All right. No, so they always squeeze in something small here. That's what they do. They're always interested in squeezing something small. Yeah. I'll give 20 more seconds. Close it. Okay. Fine. All right. So how do we go about this? Let's say that, hey, if I just call this outer square as A, B, C, D, and there would be some center O here. And if I call this fellow as P here, Q here, and R here, or P, Q, R, C, another square there. Let's say that, hey, this dimension is X units. Let's say that this square has a dimension of X by X units. All right. So let's say that this is Y here. All right. This particular portion is Y units. From O to C is Y units. What I'm trying to say is O to C. Only O to C is Y units. In the sense the complete dimension is 2 Y units. Complete dimension. If we want to understand the complete length of this bigger square, it is going to be 2 Y units. Out of this, if this is X here, I can write this as 2Y minus X. If I just want to know what is B to P, I can write this in that particular fashion. Fair enough. All right. That's one way. Second thing from here, do two constructions. If you are interested in this, I'll do 2 constructions. I'll one construction is write it from here till here. This is one construction. Right? You can do this one construction there. So then you can focus on this portion of the triangle. You can focus on this portion of the triangle. What is this? Let me call this as R, radius of the circle. Let me call it as R. Therefore, R square is equal to, in the hashed one, you can write this as Y square plus 2y minus x whole square, right? So what 2y, hang on, that is nothing but 2y square. Sorry, what is this? Already know what is this R here? This R is nothing but 2y, right? This R, no, R is not 2y, so y there. So let me call this as R itself. Let us call this as R itself. R square is equal to y square plus 2y square. Let me initially, because the whole of this particular length, this whole length is what? This whole length is 2y. The whole length is 2y coming here. I'm referring to this. Don't break it. I'm just referring to this. This is 2y. That is one side of the circle. What did I do? I looked at the bigger triangle O, P and C. One length is y units. The complete length of BC is nothing but 2y units. I took a square of that. Fair enough. Now same R, let me define it from the other perspective. Define it from this perspective. Can I define the same R from this perspective? Let me shift this R here. So now I'm referring to the triangle ORQ. Look at that. All right. Now therefore the radius R square. Don't confuse with this particular R. Radius square. Radius square is also equal to, you say that y plus x whole square. You are saying that y plus x whole square plus a, what is this dimension? X is y plus x whole square, and I'm just giving the proof here. Basically, already in case I was not aware of certain things, you would have gone about doing this. Say, what is r square? Equate both of them. Equate this with this. This is nothing but 5y square. So write that 5y square. Let me open this particular bracket. Y square plus x square plus 2xy plus x square. This is what you kind of got. 1y square I can cut off on the other side. Therefore, you write it as 4y square is equal to 2x square plus 2xy, all that stuff. Then you simplify this. You simplify. Okay, let it be. I will write this as 2y whole square is also equal to 2y whole square is 2 times of x square plus 2 times of xy. I can write this 4y square as 2y whole square, which is also equal to 2 times of x square plus 2 times of x into y. Let's understand this. Where are these dimensions? Listen to me very carefully. Listen to me very carefully. What is 2y whole square, my friends? What is 2y whole square? 2y whole square is nothing but ABCD. ABCD. 2y whole square is nothing but A. Right? What is 2x whole square? Right? 2x whole square is nothing but this particular portion. 2x whole square is nothing but the 2 times of PQRS. If I call this as PQRC, 2 times of, let me write it as the smaller square. It is nothing but 2 times of the smaller square. Listen to me very carefully. What is this 2xy can be written as? See, this is x here. This is x here, and this particular portion, this portion is what you called it as y here. Right? Now 2 times of xy, 2xy. Let me put this 2y together. Listen to me, 2y together and then x together, and hence you say that this is 2y times of x. This is 2y times of x. That is nothing but, hey, this entire picture. This entire picture plus 2 times of the smaller picture, 2 times of the smaller picture is equal to the bigger picture. Now I can cancel this picture from here. Let me call this particular area as A. Let me call this area as B. For example, let me call this as B, and let me call this as C. What is that ABCD I'm talking about? This ABCD is nothing but A plus C. Okay. Now 2 times of the smaller means what? 2 times of B. What is this 2xy? 2xy is nothing but A. A I can cancel, and hence I can say that C is equal to 2 times of B. C is nothing but 2 times of B here. Okay, this C is nothing but 2 times of B. This A is also nothing but 2 times of B here. We can also say, and hence you say that, hey, technically I could have proved it a lot better by cancelling this 2 here. Had I cancelled 2 here, I would have made it as 2, and I just have taken this. I would have technically proved it a lot more better and faster, right? That could have been much more efficient. Ultimately, what I'm trying to tell you here is, hey, this will become, if the ratio of this becomes 1:4. The ratio becomes 1:4. After division, you understand that it will lead to 4 smaller squares. The ratio of this will be 1:4, which is worth remembering. Whenever you squeeze in a square here inside a semicircle and then try to put a smaller square, the ratio would be 1:4. I could have effectively proved it rather than doing it like this. Had I just simplified it and made it as 2y square, I could have proved it much more effectively, this particular ratio 1:4. Okay, but nevertheless, you can prove it from here. You can simplify this, take this as 2y square, which is equal to x square. X square is the smaller one, and then you take this as xy. You will be effectively able to prove this lot more better. Comfortable? Kind of made sense? Kind of made sense? Or you want me to prove this once again? Or you understood? You understood that 1:4 standard ratio. 1:4 standard ratio is clear. It's a standard ratio. It's a standard ratio. A smaller to bigger. The proof comes from here. The proof comes from here. You can just visualize this x into y. Making sense? Is this clear? Okay, if you want to understand what is 2y square, right? Y square is nothing but y by y. All right, y square, right? Call this as 2y into y. 2y square can be written as 2y into y. This whole area, this is 2y into y. This is 2y square. This is 2y into y. Where is x square? X square is this. This is x square, the green one. Okay. Now, where is x into y? The x into y is this blue one. This is x into y is equal to blue one. X into y is blue one. Therefore, you are trying to say that this piece, right? Now, which piece? Now, let me call this piece as P. This piece is equal to this piece because the other piece is common. That is all I am trying to tell there. So, if this piece is equal to this piece, then naturally, now, so all the pieces are nothing but 4 times of that particular piece. Can we take the center at C? No, you cannot squeeze a square by taking center at C, Rishabh. Center has to be here. O is the center. Otherwise, you will never get a square there, right? For smaller square diagonal. But then you need a common R, right? Otherwise, if you take it from here, it will become another thing altogether. It will not help you. It will not help you. Only premise that you are considering is what? Let the radius of the semicircle be R. And you are playing the whole game with the radius of the semicircle. You are playing the whole game with one variable, right? Basically, you are equating everything to 1. You are equating everything to 1. Clear, Rishabh? Basically, you are equating everything to 1. This is your radius. This is also your radius. You are looking from one perspective and you are closing it. Yeah. Okay. Anyway, okay. Rasul, already you were asking that what was this? It is like this. If you take a circle, we discussed in one of the lectures, previous lecture, and if you draw a semicircle, if you drop a semicircle, inside this semicircle, there were 2 semicircles like this, or it can be 2 big circles also like this. It can be 2 big circles, and then in the CAD, they will squeeze another small circle like this. They will squeeze another small circle like this. Relationship between all 3 circles. If the radius of the bigger circle, big circle, this is C1. Let me call this as C1. This pink ones, let me call this as C2. These small ones, let me call it as C3. The relationship between all these 3 is this. If the C1 is equal to R, radius of the C1 is equal to R, then the radius of C2 is equal to R by 2. Radius of C3 is equal to R by 3. That is it. This is the direct relationship. Clear? Clear? This is what we tried to do in one of the other lectures, but there it was a semicircle. That's it. But if you want to relate everything to the larger circle, if C1 is the larger circle, if the C1 is the larger circle, and if I assume the R radius has to be R there, then I squeeze 2 circles which touch at the center. Let O be the center. They touch there. And then you squeeze in another 2 circles. There are 3 types of circles, C1, C2, C3. So C2, the radius would be R by 2. C3, the radius would be R by 3. From there, they can quizzes with respect to areas, etc., etc. If it is an area, make these functions square functions. Go with the square functions, you will get it. Clear there? Yep, that is what we do. And the similar thing, this is squeezing in the squares. This is squeezing the circles or semicircles. Similarly, let's squeezing the circles or semicircles. Good enough? Yeah. I think all right, now this you guys also can take it because in the other class we tried to, that was a different CAT question what we tried to do. This is from the mensuration perspective. Mensuration perspective, you should know this. Mensuration perspective, you should know this, right? How if I squeeze in the circles, how these circles will look like. R by 2, R by 3. Standard template, standard template, standard template. Okay, guys, we are kind of approaching 11:30, right? So we said that we will have a short session, but then mensuration. What we talked about in mensuration is applications based on circle. We will talk application based on quadrilateral in some other lecture. Then we will talk about applications built on the built on volumes. That is 3D. These two are 2D. We discussed one part of 2D. There is another part of 2D, and then we will go to 3D. All right, that can be, maybe we may need little more time. Maybe a couple of maybe about 30-40 minutes here. That may be a good time. Maybe about 1 hour here. So we still need about 1.5 hours or something like this on this. We will plan it out. We will plan it out in the subsequent weeks. Yeah, that's kind of brings us closure of this particular lecture. Can I assume that we all learned something at least today? Can you please put that in out here, friends, quickly? Quick. I don't know mensuration, how much it helps. Mensuration is little bland subject, no doubt, but there are enough of learnings that can be developed from there as well with respect to certain standards. Can we assume that you at least took home some 2 or 3 points? Yeah, whatever the time that we have spent. Cool. All right. Yeah. As long as you think that something added, I'm happy, because we spent close to 80-90 minutes. Okay, guys, there are 2 more free mocks being added. So one on 7th November, one on 14th November. So anybody is looking at the mocks to be taken. So if your time slot is somewhere in the afternoon for CAT, you can try these free mocks as well. Nevertheless, please write 2 to 3 mocks in a week. At least 3 mocks is good at this stage. Try and write 3 mock CATs. Try and write 3 mock CATs every single week for at least the next 2 or 3 weeks. Do that. Last week you kind of take a decision how many you want to do. You want to go heavy, you want to go light, that you can kind of decide. If anybody is taking the mock and not registered, you can use my code Belvi100 as an invitation code, and you could do that. Okay, tomorrow we will meet again. So same time at 10 p.m. Or should we take a break tomorrow? What do you guys think? Should we meet again tomorrow? 10 p.m. Yeah? Yes, no? Somebody can put that in the chat. Yeah, we can meet. All right, cool. Okay, so if you have liked what we discussed, please like this. All right, please like this particular video, and then subscribe to Cat Ninjas, our program, so that whenever we start the lecture, you kind of get the notification. Hop on to the Telegram group just in case you want to get the link for the lectures on a regular basis, or whatever it is, right? So I'm sure all of you are all technically savvy. You guys can get that. That should not be a great thing. Yeah, if you have genuinely liked this, then put it as a like and then proceed. And you have any comments post lecture, please go ahead and you can put that in the chat, which is comment section of the video. I will come and read, and if something has to be responded there, I will certainly respond. Fair enough. Good night to all of you. So I will see you guys tomorrow night, same time, say about 10ish tomorrow. Bye till then. Good night. God bless you. Good night.